So today we kind of go back over all our probabilities again, our conditional, our theoretical, and then some of our experiments, observational studies, and surveys that we were talking about before. So for these first couple, we're going to keep it really basic. So for these first couple, we got a bag. We got some chips in there, some red ones, some blue ones, and some yellow ones. A chip is selected. Here comes a key word. That's why it's all caps. Replaced, and then another chip is chosen. So in other words, we're going to have multiple events going on here. But before the next event occurs, whatever chip I pulled out is going back into the bag, which means my probability to get that particular thing would be the same. So the first thing I want to do is see, okay, how many total chips are there in the box? Because we've talked about when we're doing probability, one of the things that we need to know is what our sample space is. And in this case, my 72 total chips would be my entire sample space. So once I have that, that lets me know when I get to my first probability here, okay, the probability of getting blue. Whatever it is, it's going to be out of 72, because that's how many chips are in the bag. So blue is 18. Okay, I have an 18 out of 72 chance of getting a blue. So it goes then red. So we got to visually kind of think about this. Okay, I pulled a blue chip out, it's in my hand. I put it back in the bag, it's replaced, which means there are still 72 chips in the bag when I reach back in looking for a red one. Now once I get here, I could try to reduce the individual fractions. I don't have to go that route. Otherwise, all I would do is I can do this a couple of ways. I can either multiply straight across, and then reduce that fraction as much as I could. Math, enter. 25 over 288, okay? Simple, fine, you can just leave it that way. If you wanted to do it a little bit quicker, if we put parentheses around our fractions, when we're multiplying them originally, and I'd have to have the parentheses, and just hit math, enter, it'll go straight to the answer right away. It'll do all the reducing and multiplying in one step. I brought it to the same place both ways, though. It's just kind of up to you. So then the same thing on number 2. The setup's going to be the same. We're still replacing. So you're like, okay, this shouldn't be too bad. I can kind of whip through this one. Yellow is 29. I put the yellow one back in the bag, so there's still 72. Then I want a blue one. So I've got the same situation that I had on number 1. I can either parenthesis them and do it, or I can multiply and then reduce. I'm just going to go ahead and parenthesis the first time this time. Except I got to make sure I type it incorrectly. That's kind of important. So 29 out of 288. But it does stay as fractions. Do not give me the decimal form of that. Now, we make one slight change as we go to the next 2 questions, but it's a big change. Besides the fact that it's pizza and it's yummy. So we have this box of pizza with all these slices. Mark randomly chooses a slice. Eats it. No replacing it. If you're eating it, it is gone. Okay? So you're like, okay, so, what big difference does that make? Well, let's do like we did up here. We needed a total. We needed to know our sample space. So 3 plus 7 plus 5 is 15 total slices. Okay, so I know my first fraction is something out of 15. And I want a cheese piece. Okay. So here's where life changes. There was a 3 out of 15 chance of me getting a cheese slice. Well, I got it. It's in my hand, and all of a sudden, insert burp, burp. Okay. Cheese slice is gone. I ate it. So now, there's only 14 slices left. That's the difference. And then next I look for a supreme. I get my supreme. And I go about my business. And again, I can do this either way. It doesn't matter if I multiply straight across and then reduce. Or, whoops, that's not going to help me though. 15 divided by 210. Or again, if you just go with putting parentheses and do it all at once. The key here is, do you remember to lose one of the slices when you go to the second fraction? If you do, you're in good shape. If you don't, well, it's going to be a little troublesome. And then 4 is to really see if you're watching it. You're like, okay, 2 pepperonis. Now again, they're separate events. They're each going on, hey. Oh, okay. Thank you. So what we're going to do here is we're going to get that 15. Okay, we get our 7, because there's 7 pepperoni slices. But now we have, I'm just going to call it double trouble. Because now, okay, I had that pepperoni slice and I ate it. Now there's only 14. But now I've really got to watch it, because the slice I ate before is the same type I'm trying to get now. So now there's only 6 slices of pepperoni left. So I can't put 7 in again, because otherwise that'd be kind of strange how I ate it and yet it miraculously reappeared, unless I'm some sort of magician or something like that. I'm just saying. So let's kind of see here. Okay. I should know the 15 times 14. I just had it. And again, don't get caught leaving something unsimplified. Okay, so again, that's our basic, our theoretical probability. That's all there is to it. Most of the rest of these are going to have to do with some of the tables and things we were doing with conditional. But again, I still have to pay attention. Group of cell phone owners were asked whether they had an Android or an Apple phone. Use the results of the table to find the probability. Okay, we've talked about the need when we see a table. If there aren't totals, we want them. So I'm going to add my rows, and I'm going to add my columns. And what should happen is, when I total them going each direction, I should get the same number in there. And the one time I would need that value is if there's not a restriction. Now, if you've kind of been going along going, okay, what's he talking about, this restriction? Okay, when that little dash is there, and we've talked before about that replaces the word given, which is another one of our probability magic words. That's when I get a restriction. If there's no given, if there's no slash, that probability is out of your entire sample set, your entire sample space. So male that owns an Android. Okay, here's my males. Owns an Android. I get that fraction made. I look to see if it reduces anymore. It doesn't. That's my answer. Okay? Because I've had some of you approaching me with questions like that, and you're like, well, does it mean it's male over all Androids? No, there's no restriction. It's just male that owns an Android. There it is. There's my total. When the given goes in, though, okay, when the slash comes in, this is where we say, okay, what's after the slash, what's given, is my denominator, the number of males, period. Okay, not the entire sample set. My numerator is both events occurring. So owns an Apple product and is male. And so I start looking. I'm like, okay, all the males. Oh, that's why I added them up before. Okay, because I needed to know who they all were. Apple and male, I stay in the male column. There's Apple. And I get that value. So it's different than the other one that we were looking at before. 30 over 64, math, enter, enter. Okay, 15 over 32. But again, it's when that restriction comes. And it's always going to be what's after the given is my denominator. And the two events together is going to be my numerator. Now, do you have to write out the words? Not necessarily, but if this is one where you're still not sure, it's a good idea. And it's a good idea to have your examples out as you're looking at them. Android, we add up our androids. And then we stay in that row, but now I just want to find the females. Oops, I probably should do my due diligence here and make sure that doesn't reduce. Okay, it doesn't. I got fortunate there. But that's what we're looking at with these. To kind of get ourselves set. You're like, okay, you know, this stuff's really not too bad if I just kind of give myself a little bit of a chance. So then as we flip over, table below shows the number of gold, silver, and bronze medals won by the United States and China during the 2012 Olympic Summer Games. Find the joint relative and marginal relative frequencies. Okay? Joint relative and marginal relative frequencies just means we're going to do this chart in decimals. That's all it means. And for us to be able to do that chart in decimals, just like we did on our last chart, I got to add up all my rows and columns over here to see what's going on. So we will do that. And again, my rows and columns for my totals should add up to the same value. If they don't, go back and check. You probably just punched in a number incorrectly in one of your rows and columns as you go. So I do this time because every value over here in my decimal version of this is going to be divided by that number. So if I mess this number up, this entire chart is done basically. And so to get those joint and marginal relative frequencies, I take the value in the box, we divide it by 191. And with the decimals, we're going to go to 3 decimal places. So here, for instance, this would be 0.241. You're like, why not 0? Because that value after that 8 makes it go up. And so I'm going to go through on every one of these. So here, 0.147, and I just keep dividing what's in the box by that total of 191. And I'll explain one small issue that we can run into when we get to the end here. We're just going to take our time, watch for our rounding. You're like, oof. We don't run into these a whole lot. There's a whole lot of button pressing to be doing, but we'll get there. I'm just kind of checking my numbers as I go here, making sure I'm putting stuff in the right spots. We're just about to that point that we're going to be able to So you're like, okay, I got numbers for everything. Why are you saying there may be something that I'd question or have a concern with? Well, when I get to the end, if I add these two together, I get 1. If I add these together, I get 1. But if some of you are really tedious about this, you may go back and you might be checking your columns, and you go, okay, well, let me add up this first column. And you start going, and you go into a panic. You're like, wait a minute, I got 0.539. This is like 0.540. I'm going to get something wrong. When we're doing this much rounding to 3 decimal places, we're bound to be off a thousandth here and there. Don't let that concern you, okay? I mean, if you'd been like way off, that's one thing. But as long as these add up at the end, your other ones are going to be okay. We're just kind of watching that. That's all I'm going to be using, though, to build this chart. Once I get to here, okay, once it says find each probability, we are back to making fractions. No more decimaling. Okay? So once I get here, my lock is going to be on this stuff right here for when I'm in this area. Whoops. For when I'm in this area. There we go. So here, probability of U.S. bronze medal. There's no given. There's no slash. It's my entire sample space. Probability of a U.S. bronze. U.S. bronze. Make sure. Same thing. Now, here's the one thing that I've got to watch for with those. You're like, okay, no slash. It's out of 191. Now, that's true. Gold or silver medal. You're like, well, that's 2 different things. How do I do that? If I see or, it just means, okay, a gold. It doesn't say which country. There's 84 golds. Or silvers. There's 56. Okay, so if I see that word in there, 4 plus 56 is 140 out of 191. We'll double check. Nope, still 140 out of 191. Okay. And I get that set. And you could make them 2 separate fractions and add them together if you wanted to as well. But for the rest of them, we all have our given. Okay? So the ones where what's after the slash is my denominator, the 2 together is my numerator, and now my sample space starts to shrink. China. 88 Chinese medals. Okay, what about silver Chinese medals? 28. 28 over 88, math and Renner. 7 out of 22. And so as I'm doing these, we should at this point be kind of into a groove. Gold. So, ooh, that denominator, it can be a total down here or over here. It's true. U.S. gold. 46. My answer. Now, these last 2, I throw a little twist in. So I want to see how focused we are. Not silver is my denominator. And China, not silver, no, not sliver, silver, is my numerator. Now, I could actually think of this one a different way. Because if it's not silver, then it has to be gold or bronze. So another way you could look at this would be gold and bronze on the bottom, and china, gold, and bronze on the top, depending on if you don't want to subtract but add things together. We're all different that way. So no matter which way I look at it, okay, not silver, or gold and bronze. Okay, gold is 84, bronze is 51. So 84 plus 51, 135. Now, china, gold, and bronze, because that's not silver. So china gold is 38. China bronze is 22. 60 over 135. Or 4 ninths. So it depends on how your brain works. If you just want to be able to add up the stuff that's true, you can do that. If you want to say it's not silver, you're going to end up adding up the same stuff. But you can do it that way. And it's the same way on this last one. So let's just think about this for a second. Not China. Well, in this case, if it isn't China, it has to be the U.S. My numerator is just normal this time. It's bronze. So this would be, okay, U.S. bronze. Or you can say not China, but that's really what you're doing. So U.S., total up the U.S., okay. U.S. bronze. Give it the quick check. Make sure it doesn't reduce anymore. It doesn't. And we're good to go. So we've got to keep playing those as we're doing this. 7. Now we'll switch it back up a little bit. A die is rolled, and then a letter in the word statistics is randomly selected. What's the probability of, first part, at least a 3? So let's think about a die. I've got 1, 2, 3, 4, 5, 6. At least a 3. 1 is not at least 3. 2 is not at least 3. 3 is at least 3. So 1, 2, 3, 4 out of 6 possibilities total. My sample space is all the numbers I could get. Then the letter S. So I go through my word here, and I'm like, okay, S's. 1, 2, 3. And how many letters are in my sample space? Well, however many letters are in the word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's still multiple events. And again, I can multiply straight across, or if I put my fractions in parentheses, I can get there right away. Again, you've got to take it in pieces. So I keep rolling here. All right, the spinner below, I guess the spinner to our right in this case, is spun. Find the probability that it lands on an odd number, oh, magic word, given it lands on a white space. Okay, whatever's after given, white space, is my denominator. And the two events together, which is white space and an odd number, is my numerator. So for those of you maybe going, okay, I can barely tell the difference here. Here are my colored spaces, okay? So there's 1, 2, 3, 4. 4 white spaces on the spinner. And how many of those numbers are odd? 9 is odd. 7 is odd. 8, nope. 6, nope. 2 out of 4. 1/2. Okay. But I mean, it could be the word given. It could be a phrase like, it is known that, or you know. Okay? I've got to look for those keywords when I'm doing this to know if there's a restriction or if it's just the whole spinner. Stuff that we've seen. Now, as we start to get through towards the end of some of these, I'm not going to do every single one because we're going to see some repetition, but I am going to try to hit on some things that are a little bit crazier. So the one thing I will do for sure as we're doing this one is anytime, as I've said before, that we see a chart like this, first thing I do if totals aren't there is I want totals because I'm probably going to need them. Because one thing I notice as I start to look at these, there's the given bar on both of them. Okay, so I'm not going to be using the grand total here. Now here's the one thing I will do on one of these. I'll do number 10. So the probability of being a 9th grader given they are not on the honor roll. Okay, there's actually a column for honor roll no. So I don't need to do an opposite here. Not honor roll. 500. 9th grader. Not on the honor roll. Okay, here's my 9th graders. Here is not on the honor roll. So there's 120. And reduce my fraction. But again, you'll notice things are going to keep switching back and forth. I want to see if you're paying attention to the types of questions you're seeing. Okay, 11. We go back to our theoretical probability. A sack contains 7 blue, 3 red, and 12 green marbles. Totals are always important because that's my sample space if I need it, and I'm going to need it here. If you draw a marble, replace it, then draw another. So we're going to do D and then C here, just to kind of change things up a bit. Okay, probability of it not being blue. I know there is 12 marbles. Okay. How many are not blue? Well, I could subtract the 7 from the 12. I could get it that way. Or I could just say, well, if it's not blue, red and green, they're not blue. 3 plus 2 is 5. But there's one event. And so that's my answer. On these others, there's all 2 events going on. Red then green. Multiply the 2 individual ones together. Red then red. Multiply them together. Here's the one oddball. Red or blue. Okay. So I look. Red or, there's only one event going on here. Okay. Red then green. 2 events. I'm doing it twice. Red then red. 2 events. I'm doing it twice. Red or blue. 1 draw. What's my chances of getting red or getting blue? Pretty good. And I get my answer. Okay. So if you see the word then, you get a comma that are separate events, you're going to be multiplying 2 things together. But if it's just one statement, it's one event. You're just going to make one fraction and you're going to reduce it. So again, best way to get used to that, practice, 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 practice. Okay. So I get here to this last one and I'm going to, again, I will help with numbers. Make sure I squeeze them all in here. Again, this will be part of your job tomorrow. And as I've been kind of saying again and again as we've been doing these, to determine if your fraction is going to be with your total sample space or if it's restricted, you have either got to see the magic words, given, known that, or that slash mark. If you don't see that, don't see it, it's out of my total sample space. Probability I have less than a high school education. Good. Earns over $30,000 and less than a high school education. Not two things. Over $30,000, less than a high school education. Still only one box to put it in. Okay, no restrictions. It's just which one of the events in the table am I using. Now the last one, again, now I've got the magic slash. Above a high school education. Ooh, I don't see a column that says that. Okay, above. Is less than high school above a high school education? No. Is high school above a high school education? No. So this, in actuality, is saying some college plus college degree. So you can get a restriction that's multiple pieces of your chart, because that's what above high school is. It's these. So I add those up. But now I want over 30,000 and either some college or a college degree. So I'm like, okay, let's see. Over 30,000. Some degree, 143. College degree is 245. So it's a little more compound than just what we've been doing on some of the others. So 388 out of 874. And those aren't the types of questions that I will be answering tomorrow during this quiz. Well, did I do, what's the total? Practice them. Okay? And then our last part's what we've been doing recently. This whole survey, experiment, or observational study, and then see if there's some bias. Okay? A television station invites viewers to call in and name their favorite game show. You could argue a couple of things here. Okay? If you're calling in, could it be a survey? I suppose, but call-in normally doesn't do it. Experiment? No, I'm not making people do anything. Observational study? I'm not sitting back and watching them, so I'm probably going to go with you on this one, that this one's probably a survey. Could there be any bias? You're telling people, call in and tell me what your favorite game show is. Probably not. Now, I guess if they invited them to call during a game show and they're trying to get you to say, my favorite game show is Price is Right, and you do it during Price is Right, I suppose. But it doesn't seem like it. So probably not. But if you could come up with a reason for it, as long as it's reasonable, it's okay. A school principal gathers an alphabetical list of all the students in the school. She selects every 15 students to take a survey about the cafeteria's lunch menu. All right, let's see. This one's kind of obvious. The word survey is right in there. Could that be a problem? Every 15th student did it in an alphabetical list. She's not just picking the seniors. She's not just picking the sophomores. It doesn't really matter. So again, no, not really. Now somebody may say, well, what if they don't eat the school's lunch menu? Well, then hopefully they'd say, I'm not going to talk about it. But maybe somebody would and say, your food sucks. I don't eat it, but it does. I don't know why you would do that, but okay. All right, something's got to change up here in a minute. Get those back over there. All right, writing. A group of television producers plan to survey 10-year-olds to determine their opinion about a new cartoon. Describe a sampling method that could be used to gather a biased sample in this situation. Then describe a method to gather an unbiased sample. Okay, so you are a TV producer. 10-year-olds, you want their opinion about a new cartoon. You really want them to pick the cartoon that you are showing them. How can you get a 10-year-old to say they like something? Guy, there we go. Okay. Give them candy while they watch it. They get a positive experience while they're watching the cartoon. They say this is the greatest cartoon ever, and you've gotten what you wanted. Okay. But what if I wanted their honest opinion? 10-year-olds are pretty honest. So maybe it's just, you know, just watch the cartoon in a normal room. Watch the cartoon in a room without adults telling them what to think or something like that. But there's not a whole lot I'd have to do, because you're right. Yeah, 10-year-olds typically will tell you what they think. So I'm not looking for anything fancy here where you've got to come up with an entire plan and it's this and it's that. You don't have to go into all that. But just enough to say, here's how I could kind of get them to think a little bit. And then we're kind of in the same situation here. Your classmate is randomly selecting a sample of students at the high school to take a survey. You say your classmate's sample is biased because it only contains high school students. In what case might you be wrong? Okay. Randomly selecting people, that sounds like a good plan. But you're thinking it could be biased because it's only high school students. What would be an example of a good survey to take that would only contain high school students, where I wouldn't want to know what people think outside these four walls? Lots of examples. Yes, this is still running. Okay. I was just trying to let people still know we were rolling here. Yeah, let me ask it this way. What's something that goes on at school that people outside of school wouldn't care about? Okay. So let's say I would be wrong. Survey is about school dress code. Survey is about, I don't know, I'm just making stuff up as I go. Prom themes? Okay. You know, our 10-year-old from question 17 isn't going to care about your prom theme. Okay? Most adults are probably not, that are outside the school, going to care about your prom theme. So there, having a very select group of students is what you do want. It's not biased. But if you just ignore that, you know, in many cases that could be biased if it's a very specific group. So again, tomorrow, shock, shock, 18 questions on the summative. Okay? Be ready, go over things, have your homework check ready so you can get yourself an opportunity to do a retake if you need it, since we only have a couple left. And we'll see you done.